Hello, my lovely students. How are you again and again? Today we're going to complete the second part of our lesson, which is another way to change matter. We took two ways to change matter. We have the first way, which is physical changes, and the second way is chemical changes. We said physical changes happen when we change the matter, but we don't change what it's made of. Matter stays matter. Chemical changes happen when we change matter to make a new matter. So matter changes to make a new matter. The song of physical change. Physical change happens when something changes, but the kind of matter stays the same. And the song of chemical change. Chemical change happens when matter changes and becomes a new kind of matter. And this is our lesson, the chemical changes. Chemical change happens when matter changes and becomes a new kind of matter. We said we cannot change matter back into the first matter. We cannot. We talk burning is the first example of chemical changes. And we talk the cooking, which is the second example of chemical changes. But we forgot to highlight, so let's highlight this part of our lesson. We said a chemical change happens when you cook eggs. A cooked egg is different from a raw egg. This is raw egg and this is cooked egg. And we have fried egg. The cooked egg has a new color. Look, here we have white color, but here we don't have the white color, only we have the yellow color. A new color, new size, shape, and texture. So, the cooked egg is different than the raw egg because we have different color. Here we have white, here we have uncolored, and the yellow here. Different size, this is bigger than this one. Different shape, look at the shape of this one and the shape of this one. So we have different texture. Yes, the texture here is different than the texture in the raw egg. You cannot change a cooked egg back into a raw egg. And because of that, this is chemical change. Cooking vegetables is a chemical change. Their color, size, shape, texture, and taste become different. You cannot change them back to the way they were. So if you have cooked food, you cannot return it back into the first matters. So cooking vegetable is a chemical change. And we have different color, size, shape, texture, and taste also. Draw it, okay, here, underline. So we have to use our pencil now. Okay. Underline the sentence that explains how cooked egg is different from a raw egg. Here, the cooked egg has a new color, size, shape, and texture. Okay, this is the answer of our question. Okay, boys and girls, and we said we have different color, have different shape. We produce odors. sometimes sounds, lights, different tastes. These are the clues of chemical changes, which is color, smell, texture, taste, shape, and size. Okay? Okay. Now, the third example of chemical changes, it's baking dough. Baking dough or cake. Baking dough or cake. Baking changed the matter. If you have, or if your mommy make dough and she baked this dough, the dough changed into bread. Okay? So if your mommy made dough and she baked the dough changed into bread. Also, the ingredients of cake. If you bake the ingredients of cake, if you mix in the beginning the ingredients of cake, if you mix them together, then you bake them, you will make cake. Cake is a new matter, and the cake is different than the ingredients. Also the bread. The bread is different than the dough. So if you make dough and you bake the dough is changed to bread. The dough is baked and we have a new matter, which is bread. Look here. This is the dough. This is the dough. Here we have baker. Here like your mommy. Okay. Here we have dough. They made dough. Then they put the dough in the oven. Look. The dough is baked. And we have a new matter, which is bread. We have bread. Look here, we have different kinds of bread. So, dough turns into bread. So, dough stays dough? No. Dough is changed to new matter, which is bread. Also here we have the ingredients of the cake. We mix them together, then we put them in the oven. When we put the ingredients in the oven, the ingredients are baked. Look, and cake is produced. Okay? So cake is different than the ingredient. Right? The cake is a new matter. To know more about the baking, I want you to see our friend and he will explain what happened.
And a physical change is where I can change what something looks like. I have a piece of paper, I crumble it into a ball, I've changed what it looks like, but I don't change what it's made.
This is physical change or chemical change. When he crumbled the paper. Paper stays paper. So this is physical change.
Made of, I don't change the stuff it's made of, I don't change the matter that this paper is made of. Through science, we've discovered, yes, we can change things physically, but we can also change things chemically. So let's show you a chemical change. I need to put on my safety glasses. I need to get a match.
He's wearing a safety glass because he is using match, and this is danger.
And I'm going to try to change this paper chemically. blow that out, let that go a little bit, and I'll blow this out. So we've zoomed in so you can take a closer look at what we're left with. And what are we left with? We have all of this stuff that started out like this white paper, but it changed.
So the paper is changed into what? Yes, we have a new matter. So paper is changed to new matter. Paper is changed to ash or char. Okay?
It changed chemically. It's no longer that white paper. It's black and charred, and even the match head is different too. That's because it's changed chemically. One of the clues that a chemical change has taken place is that a new substance is created. We could see that new substance when
So in the chemical change, new substances are created. New matter is created. So matter doesn't stay the same matter. Matter is changed into or to new matter.
when we burn the paper, but sometimes we can't see that new substance. Sometimes that new substance is invisible and just goes into the air. Well, today we're going to try and take a closer look at that invisible substance that can be created in a chemical change. A lot of times when you hear chemical change, you think explosions and fire. But chemical changes happen around us all the time, and we may not even think about it. Take, for example, this piece of bread. So we've zoomed in, and what do you notice? Well, I notice all these open spaces, these little pockets.
I want you to focus on the open spaces, okay?
Some are small here, but this one's big. Well, where did those come from? All of these air pockets were caused by a chemical change. When I mixed all of the ingredients together to make this bread, a new substance was created. So why does bread rise when you mix all the ingredients together? Well, that's because a chemical change is taking place. All the ingredients mixed together and a new substance is created. That new substance is carbon dioxide gas. One of the ingredients in bread that's responsible for that chemical change taking place is a living thing. I'm going to pour some of it out. Right there. What is that? We've zoomed in so that you can see a pile of yeast. And believe it or not,
I want you to ask your mommy about the yeast, okay? This is a living thing. You have to know that the yeast is living thing.
this yeast is alive, but it needs the right conditions so that it can grow.
The yeast needs right condition to stay alive, okay?
So here's our yeast, and we have warm water and sugar. The warm water.
We have warm water and sugar. Warm water and sugar. And these are the suitable conditions for the yeast.
And sugar are going to give us the right conditions for the yeast to grow, and we're going to see if we can.
So the right conditions to yeast to grow, okay? To see how the yeast is living thing.
Can capture the new substance that's created when a chemical change takes place. Now I'm going to put a couple scoops of sugar into the water. Stir it up. You can see I'm a little messy. That's okay.
Now here we have what? Solution, right? And the solution is physical change, right? And we can separate the solution by evaporation. The sugar and the warm water are the right conditions for the yeast to grow. You have to see what he will do.
And while that's dissolving, I'm going to dump some yeast into my bottle using my funnel. So I have the two things I want to mix together. I have my yeast and I have my warm sugar water. And I have a balloon that I want to put on top of my bottle so that I can capture the carbon dioxide that's given off because of our chemical change. So here we go. Let's dump some of our warm sugar water in.
He pours sugar and water into the yeast, okay? And he will cover the bottle by the balloon. Do you remember the previous experiment by using the vinegar and the baking soda? The same thing, we will produce carbon dioxide, but you have to see and focus.
That's good enough. Let's take my balloon, really stretch it over the top. I want to get my balloon down as far as I can on the bottle, and I'm going to use a rubber band just to make sure it stays on top of the bottle. So I'm going to swirl it around just to mix things up, and it doesn't really look like anything's happening, but that's okay. This chemical change is slow. It takes time.
This is a slow chemical change, okay? Slow. So you have to wait to see what will happen.
Like watching bread rise. It's important to keep in mind that chemical changes can happen slow or fast. In this case, the new substance being created is carbon dioxide gas, and you can see it's not happening that quickly at all. So why don't we try and mix two different things together to create a chemical change which also creates carbon dioxide gas, but this is going to happen much more quickly. The two things we're going to mix together to make this fast chemical change is vinegar and baking soda.
Ta-da! We made the same, but we made this experiment, but we will make it in different way. So focus. Vinegar and baking soda. He will mix them together, and we know bubbles are created, right? But I want you to see. So carbon dioxide is created here in this experiment, but you have to see how he will do this experiment.
So I need to put my safety glasses on. And this chemical change happens so quickly, we're going to have to slow it down or delay it a little bit by putting the baking soda in a tissue and then dropping it into the vinegar. If we didn't do that, as soon as the baking soda mixes with the vinegar, we'd have a really fast chemical change, a new substance would be created, and we'd have a big mess on our hands. So I'm going to take a tissue, and most tissues actually have two layers of tissue that I can separate. I pull the tissue apart, and now I have a nice thin layer of tissue. I take my baking soda, put a healthy amount of baking soda on my tissue, and now I just bundle it up, take a twist tie, and I have a package of baking soda. Open the vinegar, pour some into the baggie. All right, so I'm ready to go. Now, just before I drop in the...
Here we have vinegar in the plastic bag. Now he will put the baking soda.
Baking soda into the baggie. We're going to zoom in so you can take a closer look at what's happening. All right, let's drop it in. Now we have to make sure the baggie gets sealed completely. So I'm going to take my time and press. And I can, if I look, I can see the chemical change is already starting.
Can you see the chemical change? We have bubbles. And if you can hear the sound too.
I see some fizzing, some bubbling. Well, those bubbles are carbon dioxide gas. Remember, a chemical change, something new is created, a new substance is created, and in this case, it's carbon dioxide gas. Same carbon dioxide gas that is created with the yeast and the sugar water. It's happening a little slowly because the vinegar is seeping in through the tissue, and now what should happen, that new carbon dioxide gas should start to fill the baggie. If I want to speed it up a little bit, I can shake it. And we can see the baggie's going to start to fill up.
See how the bag will increase its size.
I wonder what will happen if
the plastic bag is filled with carbon dioxide. Okay, this is chemical change, and it's fast chemical change.
Enough carbon dioxide gas is created to plump the baggie up. What do you think's going to happen? The baggies
What do you think? What will happen? Boom.
looking pretty full. So did you hear that pop? What was the pop? Well, remember, the baking soda was mixing with the vinegar to create a chemical change, and in a chemical change, something new is created. In this case, it was.
So, do you hear the pop? This is the sound I said for you. We have sonic clues of chemical change, right? Here we have what? Sound. So sound is created, right? A new substance is created too. What is it? Carbon dioxide. So carbon dioxide is created. We have vinegar and baking soda. And we mix them together so they change into what? Into carbon dioxide. So new matter is formed, new matter is created. So this is a chemical change, and we cannot return the vinegar back and the baking soda back. Okay? And this is a fast chemical change.
Carbon dioxide gas. And so much carbon dioxide gas was created inside the baggie couldn't keep itself closed. The air forced its way out, popping out of the bag. Remember, carbon dioxide gas, hey, we actually have something happening here, but
look, something is happening here. Look at the balloon.
remember, it's slowly happening. Here, it was much more quickly. So we've turned the overhead lights off a little bit so we can better see what's going on inside of our bottle. But take a look at our balloon. Remember when we first poured in the sugar water into the yeast, nothing really seemed to happen, but our balloon's a lot bigger. What does that mean? It means all of this carbon dioxide gas, because of a chemical change, is being created, and it's filling our balloon, and you can see it's filled our bottle. And take a look at the bottle. We've zoomed in so you can really see this up close, but take a look. The tiny bubbles in the bottle of carbon dioxide gas look very similar to these tiny.
Look at the bubbles here and the bubbles here. The bubbles in the bottle and the bubbles in the piece of bread. They look similar, right? They look the same. Almost the same. Look.
Little craters or holes in the bread. That's because that's what made all of these little pockets in the bread. Carbon dioxide gas from the chemical change of.
So here we baked the dough, okay? So carbon dioxide is created. Because of that, we have these bubbles or these spaces
of yeast reacting with the sugar. It's important to remember that chemical changes are happening around us all the time. Do you remember how we said yeast is a living thing? Well, we're a living thing, and chemical changes are happening inside of us all the time. If you want to learn more about chemical change.
Okay. I hope you understood what happened here and here. So baking dough and baking cake. Bring your highlighter. Yeah. When dough is baked, a chemical change happens. When dough is baked, when you put the dough in the oven, the dough is baked. So, chemical change happens. The dough is changed into bread. The dough is changed into bread. So, we have dough and we put the dough in the oven, so the dough is baked. The dough changed into bread. The dough is changed into bread. The bread has different size, texture, smell, taste, than the dough, right? We have different, look here. Look, we have different. Look at the size. Look at the shape of the dough and the shape of the bread. The smell. The odor of the dough is different than the odor of the bread. I like the bread, the bread's odor. It's yummy. And also the texture. The texture is different than the bread, right? You cannot change the bread back into dough. We cannot. Because of that, it's chemical change. Okay, boys and girls? So, when dough is baked, chemical change happens. And we cannot return the bread back into dough. A chemical change happens when a bread is baked. Explain, why does a chemical change happen when baking bread? Why does a chemical change happen when baking bread? Said bread or making bread is chemical change because the dough is changed into bread. So I want in the beginning to write dough is changed into what? Bread. And the bread is a new matter. Bread is a new matter. And when we have new matter, this is chemical change, right? So new matter is created, so it's chemical change. Dough doesn't stay dough. Dough is changed into bread. So matter doesn't stay the same matter. Matter is changed into new matter. So because of that, baking bread is chemical change. So can you return the bread back into dough? No, we can't. You can't change the bread back into dough. Okay? So you know now why does a chemical change happen when baking bread? Because a new matter is created. A new matter is formed. What is the new matter? The bread. Good job. The last example of the chemical, which is rusting. Rusting metal. So if you leave iron in the air and the moisture for a long time, iron can rust. Rust is different from iron. Rust has different color and is much weaker than iron. Look at the ring here, the iron ring, and this is the rust ring. Look, they are different color. Look, it's silver and here it's brown, right? Silver and brown. That's mean different colors. And this one is strong because the iron is strong metal. But the rust metal or the rust iron is weak. So this one is weaker than the iron ring. Look at this and this. They are the same? No, they are the same shape, but they are different. This is, we called it rusting. Rusting. C. Here we have iron, and here rusting iron. Look how it's weak. We can break it. Can you break this one? No, we can't. More time and we can break it. Here we can. Look, this piece, I can break this piece because the rusting iron is weaker than the iron. I want you to see this video. Then we will complete. See, please. This is story. Rusting of iron. When a piece of iron is left outdoor, okay, in the open, for a while, a film of brownish substance gets deposited on its surface called rust. So, if you leave the iron outside, after a while, it becomes brownish. The brown color means we have rust, okay? Look, this is rust, this is rust. These are rusts. This robot will tell us his sad story. So, read my sad story. So, he will tell us his story. He used to be like this. Look. Clean, neat, fresh. And this is iron. But then my life turned upside down. So his life turned upside down. So this robot is changed. Water vapor. Oxygen. Water vapor and oxygen because he is outside. Okay? So we have water vapor from the air and oxygen also in the air. Water vapor and oxygen forced me to rust. So they turned him to rust. Okay, rusting occurs when iron is exposed to oxygen in air and water or water vapor. So we have oxygen and water or water vapor. And the iron. Rust king. Rust is iron oxide. Because we have oxygen and water, you have to see the equation of rusting. Iron. Iron. This element is iron. Oxygen. And water. So the iron was outside. So we have in the air we have oxygen and we have water vapor and sometimes water from the rain. This is the iron oxide, which is rusting. This is iron oxide. Help, help me, save me. But no one helps him. No one listens to him. In areas that have higher humidity, the rusting process takes place faster as the content of moisture in the air is higher. So, if we have humidity and we have more moisture, so the rust becomes too much. The iron. So rusting process takes place faster
I don't believe this.
because of the moisture. This process of rust formation is the presence of oxygen and water, or water vapor is called rusting. So, if you have iron and you leave the iron outside or outdoor, so the iron will mix with the water or water vapor and the oxygen. What will happen? We will have a new matter. New matter is created. And we have rusting. Rusting. And this is his sad story. Okay? But I wanna to show you JR. His name is Robo JR, and the status is, look, he's so sad. My rusted friend list. So iron gate, car. These are his friends. Okay. Bring your highlighter. I hope you understood what they mean by rusting. Rusting of iron. What happens if you leave your bike in the air for a long time? Look. What will happen? Good job. Over time, iron can rust. Iron can rust. Rust is different than from iron. Different than iron or different from iron. Rust has different color is much weaker than iron. Rust cannot be changed back into iron. Okay? So, iron, if you leave your bike, your toy, which is made of iron, if you leave it outside, outdoor, after a long time, iron can rust. Rust is different from iron. Rust has different color. It's brown color. It has a brown color and is much weaker. You can't break it. So it's much weaker than iron, but we cannot return the rust back into iron. Rusting iron is chemical change. Why? Because a new iron is changed into rust. Rust is a new matter. Rust is a new matter. And we cannot return the rust back into iron. Okay. Look here at the rust. Why is rust different from iron? Why? Can you tell me why? Let's see this picture. Why the rust is different from iron? Can you tell me the difference? Yes. The rust is different in color, right? Rust has brown color, the iron has silver color. And the iron is strong, but the rust is weak. The rust is weaker than the iron. We can break the rust, but we cannot break the iron. Can you break the iron? No, we can't. Only Iron Man. Okay. Here. So I wanted to write something, but I have to, yes, here. Iron changed to rust, right? Rust is a new matter. So rust is created and the rust is a new matter which is different than the iron. Why or how rust is different than the iron? Rust has brown color. Okay, also it is weaker. Why it's weaker? Because we can break it. It's weaker than iron. Okay. Can you change rust back into iron? No, because of that rust is chemical change. We cannot return or change rust back into iron. Okay? These are our examples of chemical changes. We have four, we took four examples: baking, rusting, cooking, and the first one was burning. cooking, baking, and resting. We cannot change the new matters back into the first matter. Because of that, these are chemical changes. What do you mean by chemical changes? Do you remember the song? Chemi. Do you remember the song? Chemical changes happen when matter changes and becomes a new kind of matter. Chemical change happens when matter changes and becomes a new kind of matter. I love you all. Study well and do the exercises. You all, if you can, when your mommy make cake or any chemical change in your home, make video for us. I will be happy. But if you can, love you all. Take care and have a great day. Bye bye. Bye, lovely boys and girls. I love you all. Study well.